Welcome to POIC's e-learning and certification services. This is fourth video session in the Python programming series, and in this session we are going to learn how to perform various operations on Python's primitive data types covered in previous session. So let's get started. In programming languages, symbols are used to specify operations. These symbols are called operators. For example, this symbol represents assignment operation in Python. So we call it assignment operator. These symbols represent increment operation. So we call it increment operator. Sometimes an operator is used to specify more than one operation depending on context and type of operands. This feature is called operator overloading. So let's start with simple arithmetic operations. The operators in a table are arranged in their order of precedence, higher to lower. So exponent operator has higher precedence than modulus or remainder, and so on. So let's take two numbers in ideally window and run these operations one by one to get an idea how do these operators work. So I'm taking a number 4, first operator from table, exponent, and the result is 16. I'm taking 25 and second operator, modulus, from the table, and result is 4. Modulus or remainder returns the remainder part of a division operation. So 4 is the remainder when we divide 25 by 7. The next operation is an interesting one, integer division. So I'm taking 25, dividing it by 7. This time it returns quotient part of the division operation. Next one is simple division operation. 16 divided by 4, result is there. Look at the difference between integer division or float quotient and division operation. Next operation is multiplication. So 2 multiplied by 6 gives us 12. Next is subtraction. 7 minus 4 gives us 3. Next one is addition. So 2 plus 4 gives us 6. We can also assign names to numbers. Instead of using numbers directly, we can assign names to numbers. For example, I can store 4 with the name I and 2 with the name J. So once again, I reiterate, names in Python act as pointers, and we read a statement from left hand side to right hand side. So here we have assigned a name or pointer I to memory location where 4 is stored, and a name or pointer J to memory location where 2 is stored. Now we can use these names or pointers to perform various operations. 6 is the result, but 6 doesn't have any name. In this operation we did not assign a name to 6. So 6 will be there for some time, temporarily, for some time, for limited period of time, and this type of data variables are called non-reference data variables, and they are automatically cleaned from memory by garbage collector utility, which is special utility which runs in background, and it kills or clears all non-reference data variables from the memory automatically. And since it's an asynchronous event, so you cannot predict when those data variables will be cleared from memory. So to keep your data variables saved permanently, it's a good practice to assign them names. So let us rewrite this statement. Okay, now 6 has a name k, a pointer pointing to it, and it will be there as long as your program is running. Good. So let's move on to the next slide. The next set of operations are comparison operations. So for this operations, we are going to take two numbers, 10 and 25, and we are going to assign them names P and Q. So take 10, take 25, and now we are going to run these operations one by one. Okay, so first operation to check the P is equal to Q or not. Result is false. Is P not equal to Q? Result is true. Is P greater than Q? Result is false. Is P less than Q? Result is true. Is P greater than or equal to Q? Answer is false. Is P less than or equal to Q? And answer is true. Comparison operations are like you are asking questions and Python is answering it. So Python interpreter and the shell environment we are working in currently, it is highly interactive environment. The commands are executed one line, one statement at a time, and it answers your questions in the form of results generated by those operations. Interesting? So let's move on to the next set of operations. Our next set of operations are logical operations. Operators are here on my screen, and or not. And for this, we are going to take two names again, x pointing to a memory location holding Boolean value true, y pointing to a memory location holding Boolean value false. Now, if I run this operation x and y, it's gonna give me answer false. So AND operation, as we know, returns true only when both the operands are true. In all other cases, it returns false. The second operation is OR operation, x or y. It gives us true. So as we know, OR operation returns false when both the operands are false. In all other cases, OR operation returns true. NOT is a complement operation. So NOT x is going to give us false because x is true and its complement is false. So these are logical operators. Let's move on to our next set of operations, identity operators. And this is really interesting. Let me show you how do these operations work. So here we have I and we have j. Now if I ask I is j? The answer is false. If I ask I is not j, let us take one more variable. This time I am taking a variable with a different name, let's say z, and storing the value 4 in it. And now let us ask question. I is z? The answer is true. It's really interesting, right? Why? Now see, these operations, identity operators, what do? They compare those three attributes we talked about in previous session: value, type, and ID or memory identifier. This operation, is operation, returns true only when value, ID, and type, these three attribute values are same for a data variable. So our data variable is 4. Let's check ID of I. See, ID of I is this. Let's check ID of Z. Same. Let's check type of I and type of Z. Same. This is why I is Z, return true. Let us take one more interesting example of a string. I'm taking one string, hello Python. I'm taking second string, same string with a different name. And I'm going to run this operation. First operation, S1 is S2, and result is false. Once again, interesting, right? Why? Let us check ID of S1 and ID of S2. Though both the series, both the sequences stored in the form of strings look similar, and they are similar, they are holding same value, values are same, but their memory identifiers are not same. This is the reason why this operation S1 is S2 return false. So when we use is and is not, those three attributes are compared: value, ID, and type. And when the value, ID, and type are same, then only this operation, is operation, returns true. Good. Let's move on to next set of operations. Strings covered in the previous session are versatile data structures, and working with the strings is really interesting. Now I'm introducing a special feature of string. This is called indexing. Indexing means assign numbers to data variables or members of a string in their positional order. So there are two types of indexing: forward and backward. Forward indexing starts from left hand side, and the first member gets index value 0. And since we are starting from 0, the last member or last element will have index value, which is going to be length of the string minus 1. Similarly, backward indexing is also supported in Python, but in backward indexing, the numbering starts from first thing, from right hand side. The rightmost variable or member of the string gets a positional number -1, and since we are starting from -1, the leftmost data element or member will get positional value -13. Here 13 is the length of the string. Now when it comes to find out length of a string, we have a built-in function. So I already have hello Python stored in S1 location here. I'm using this built-in function len, calling it, and len return length of the string S1, 13. Now as you can see here, let us find out what is there at index value 4 in S1 string. I'm using a pair of square brackets and index value inside it. This return the data variable or member of the string at this index value. Similarly, if I ask what is there at 6th index value in string S1, the result is P. Let us use reverse indexing or backward indexing. What is there at -7? And the answer is same. So you can use either of these two indexing techniques, forward indexing or backward indexing. Good. So let's move on to our next set of operations. And once again, we have operators. They look similar to addition operation, multiplication operation, but let us look what is difference once we run them. So I'm taking S1, I'm storing a new string in it, only hello. I'm taking S2, storing a new string, there is space, then we have Python. Okay, I'm running an operation using the same symbol that we earlier used for addition operation, but here this symbol is representing a different operation, and this is an example of operator overloading. This is an operation called concatenation. Concatenation means joining two strings. So S1 has been joined with S2. We are going to read it S1 joined with S2 or S1 concatenates with S2. Good. Similar to this, if I run this operation S1 and use this operator, be careful, this is not multiplication operation. This is repetition operation. So if I perform this operation, you see that hello or content of that string has been repeated twice. I can repeat it 10 times. It's better to keep a space for better clarity. Okay, hello has been repeated 10 times. Now there is an interesting operation you can perform on strings. It is called range slicing. How does it work? I'm taking S1 and in S1 I'll start from 0 and I'll go up to 3 minus 1, 2. Okay, HEL, first 3 elements, index value 0, index value 1 and index value 2. It has been taken out from there, it has been sliced out as a substring. Now be careful, in range slicing operation, the first number is index value from where you want to start, and the second number after colon is the index value minus 1. So this is exactly where you want to stop. So the end location, you will always have to specify the desired end location, desired end index value plus 1. Good? Okay, so next set of operations is membership operations, and these operators work on sequences, not only on strings but also on tuples, list, set, and dictionary. Strings have been covered. Rest of the data types, tuples, list, set, and dictionary supported by Python will be covered in the next session. So let us run this operation on strings. In operator performs a membership check operation and returns true if value or variable or a substring is found in the given sequence. Not in returns true if value or variable is not found in the sequence. Okay, so let's take S1 and check. I'm asking a question, is H in S1? Result is true. Okay, I'm asking question, is H not in S1? Result is false. Why? Because H is there. Let's say, what if I ask, is X in S1? Okay, false. What if I ask, is LO in S1? True. So you can check whether a single element or a substring is present in the given sequence, means in the string or not, with the help of this membership operators. Good. Okay, now Python also provide a bunch of methods, built-in methods. I keep on using these terms interchangeably, functions and methods. Let me tell you the difference between a function and method. A function is a function, but a method is also a function. The only difference is method is a special function that runs only on objects. So when we call a function to perform an operation on an object, we call it a method. So Python has a set of built-in methods. I'll share examples of count, find, and upper with you. So let's go back to ideally. This time I'm going to create a string holding hello Python, and we are going to perform the operation str1 dot. str1 is our string object. See, I put dot there, and Python has provided me a list of methods which are available and can be used to perform various operations. So let's start with count. I'm going to count occurrence of a character L in str1, and result is 2. So L lowercase l is repeated twice. There are two occurrences, so result is 2. str1 dot find. We can use this method to find out index value of a single element or starting index of a substring. So I'm giving P and the index value of P has been returned by find. Find returns index value of first occurrence of the member element in given string. str1 dot find x. Now, since x is not there in this string, find method is going to return -1. Good. Now, what if I look for starting index of a substring? So I'm giving a substring, and let's see what does find method return. It returns index value of the first element of substring passed to it. Good. Now let us run the next method, upper. What does it do? Look at this. All the characters of str1 string object has been converted to uppercase letters. Interesting. So hope you found this session useful. What did we learn here? We learned how to perform various operations on Python primitive data types: numbers, Boolean values, and strings. So stay in touch. In the next session, we are going to cover advanced Python data types. Happy learning.